Hi, I'm Phil Barber, and I'll be talking about streaming data into a MarkLogic Data Hub. The amount of data flowing into and between systems seems to be growing every day. The growth rate of those data streams is frequently outpacing even our wildest expectations from just a couple of years ago, and the volume of data is threatening to overwhelm our systems and the IT departments that support those systems. In response, data hubs have emerged as a fundamental data integration tool for storing large volumes of data from diverse sources. Kafka and the MarkLogic Data Hub both provide scalable and resilient architectures for data routing, delivery, and ingest, as well as data harmonization and transformation. Today, I will describe how Kafka and the MarkLogic Data Hub work together and complement each other. I will also demonstrate how these two platforms plug and play to solve complex data integration challenges. Much of the exponential growth of data collection opportunities comes from sources such as system status updates, event logging, and customer interactions. And this data is driving important revolutions in business use cases such as fast system recovery, system efficiency, and personalized customer experience. However, the rapid growth of data is also causing a lot of headaches. Systems that were designed for data rates a few years ago often crumble under today's volume, and IT departments are unable to manually support the growth in servers. With today's streams, every step of the data pipeline needs to be scalable and maintainable without an army of engineers. We require systems that can grow and shrink to meet our needs without stressing our IT department. That's true for the message brokers, as well as the message routers and the message processors that perform our harmonization, processing, and dissemination tasks. For messaging, Kafka has been embraced by Fortune 500 companies across many industries. Out of the box, it is a scalable, fault-tolerant, and high-performance messaging system that easily grows as your data streams grow. Built to handle real-time streams, its throughput is extraordinary. Netflix, for example, uses Kafka to handle trillions of messages per day. The previous generation of messaging software simply was not able to handle the load that Kafka is capable of handling. On the other end of the data pipeline, the MarkLogic Data Hub service is also extremely scalable. Available on AWS and Azure, DHS is a serverless, fully managed cloud data hub that provides dynamic scaling in response to changes in workload profiles with little to no interaction from engineers. One of the core functions with DHS is the ability to create flows to process your data immediately upon ingest. This processing might handle vital tasks such as routing, data harmonization, or preparation for analytics tools. With the Data Hub service, all of that runs in the background and quickly has your data ready to pay dividends to your business. That just leaves the Kafka message consumer. Kafka is designed for message consumers to run independently and retrieve messages from Kafka topics. We have developed a one-way Kafka to MarkLogic message consumer that retrieves messages from Kafka and then forwards those messages to a MarkLogic database. This message consumer is based on the Kafka Connect Java API and inherits a basic set of functionality and configurability, including Kafka's easy scalability. Just like the Kafka message brokers and the MarkLogic DHS, the message consumer can expand and contract as the rate of incoming messages fluctuates. So, as the data volume grows, DHS and Kafka can grow to accommodate tomorrow's data demands. Most importantly, this connector allows you to consume messages from Kafka, ingest them directly into MarkLogic, and automatically fire off a Data Hub service processing flow to immediately begin processing the message within MarkLogic. So your data is now part of a seamless pipeline that can expand and shrink as demand dictates, automatically route data to the MarkLogic Data Hub service, and automatically kick off a DHS processing flow. The Data Hub service can then take over with processing and additional routing. And every component is dynamically scalable and fault-tolerant, delivering the essential data you need with no code, minimal configuration, and minimal operational oversight. Demonstrating all that this solution has to offer is beyond the scope of this video, but I can show you the basic steps necessary to start streaming data from Kafka to MarkLogic without writing any code. We will start with some assumptions. We have a server set up running Kafka. We have a second server with Java installed, as well as a copy of the latest Kafka to MarkLogic connector and 2 properties files. We also have a third server with MarkLogic and the Data Hub framework running. We have also configured a canonical entity in the DHF and a processing flow to harmonize incoming data into the canonical form. Once your servers are up and running, these are the basic steps necessary to get the message consumer moving data from Kafka to MarkLogic and processed with the DHF processing flow. First, create a topic in Kafka to receive incoming messages. Second, configure the connector to be able to connect to Kafka and MarkLogic. Finally, configure the connector to send data to the DHF staging database and kick off the processing flow. Then you can begin sending messages. In this demo, I'll send messages using a command line tool packaged with Kafka. For an example of how we can use these tools to handle large data streams, let's start by looking at the Data Hub framework. In the DHF, I have defined a canonical entity called the canonical foo entity. The purpose of this canonical entity is to define the structure of our harmonized data. As data comes into the DHF from different sources and in different formats, we may want to harmonize the data to have the same format so that it is more useful to us. Once we've defined our target entity, we can create a flow to harmonize incoming data. I've defined the foo processor for this purpose. It consists of a single mapping step called foo mapping step, which will harmonize the messages we send through Kafka into our canonical form. This mapping step uses the envelope pattern, which means that when a message is processed from the staging database, it creates a document in the final database with an envelope that contains both the original message and the harmonized data. Now that DHF is ready to process messages from Kafka, we need to set up a foo topic in Kafka to receive incoming messages and make them available to message consumers. We can do this with this command line tool included with Kafka, where we specify the name of the topic, and there, the topic is created and Kafka is ready to receive incoming messages. Finally, we need to configure the message consumer. We do this by setting values in two properties files. This first file tells the connector how to talk to Kafka. So I give it the information for the Kafka host. That's all we need there. The second file is primarily for interaction with MarkLogic. In this file, we specify the topic to monitor, the MarkLogic host, the database to send documents to. Since we're using the Data Hub framework, I'll specify the Data Hub staging database, and finally, the name of the flow to run. In this case, foo processor. Now I start the connector with this Kafka command. Using our two properties files. It spits out quite a bit of logging. Takes a few seconds to load. Eventually, we'll see and confirm that it is connected with the MarkLogic database, and it's monitoring the foo topic in Kafka. That's it. Now we're ready to send messages. We can send messages to Kafka using another command line tool. This tool allows us to type in any text we want and send it to the topic in Kafka. I'll send a simple JSON message, including a foo property and value and any other information. As soon as I hit enter, you'll see in the window above the message consumer grabs the message and forwards it to MarkLogic. It's already in MarkLogic. Within a couple seconds, it kicks off the foo processor, which is already finished successfully. Now we can go back to the DHF interface and see the messages in the Data Hub framework. If I browse the data contained in the staging database, I can see the original message as I put it in the command line. If I switch to the final database, I can see the processed message. And I see the envelope pattern, which contains an attachments property with the original message, as well as my canonical foo entity property with the harmonized data. This demonstration shows how these tools can work together to create a seamless data pipeline that can automate how your systems deal with growing torrents of data. Your solutions must be scalable, practical, and they must not overwhelm IT departments with complexity or administrative demands. Today, we have seen how we can solve those problems in the real world. We can do this by using components that are each independently scalable and that the scalability can be automated in cloud environments. We can use the Kafka to MarkLogic Message Consumer as a no-code solution with only minor configuration settings. Finally, we can configure the message consumer to perform routing and to call back-end processing to perform operations such as data harmonization and analytics processing. By using these tools, we can automate virtually every aspect of the system, thereby easing the demands on the people who build and operate these systems. If you are concerned about the flood of data your systems are experiencing, I would encourage you to try out the solution for yourself. I've included links to a quick start guide to setting these tools up in AWS, as well as the code and documentation repository in GitHub for the message consumer, or you can use the link to the Confluent Hub to download the message consumer directly. Thank you for listening to me talk about streaming data into a MarkLogic Data Hub.